This is Chapter 8 for Core 2, Graphs of Trigonometric Functions. And what I'm assuming here is that you've actually come across the sine graph, the cosine graph and the tan graph. So let's go to the next page and you see this is the sine graph. You'll notice that it has a maximum, and that maximum is at 1, at 90 degrees 1. It has a minimum at 270 and minus 1. And if we go to the negative angles, minus 90, it has a value of minus 1. So this y-axis here is actually the ratio. So that's like your opposite over hypotenuse on this y-axis. And if we go to 180 degrees, if you put sine of 180 degrees in your calculator, you would actually get 0. We also notice that the cycle goes from 0 to 360, and then it would continue on and repeat itself, and also going from 0 it would go backwards and repeat itself every 360 degrees. So it has a period equal to 360 degrees. It has a maximum value of 1, and it has a minimum value of minus 1. If we look at the table below, if we convert all your angles into radians, then we've got a comprehensive table for all of them. So this one's going to be minus pi by 2, 0, pi by 2, pi, 3 pi by 2 and 2 pi. And if we look at the y value, at minus 90 degrees it's minus 1, at 0 degrees and 0 radians it's 0. At pi by 2 radians we could put little c's on there to say that it was circular measure as well, just to be more exact. So at pi by 2, which is 90 degrees, it's 1, 180 it's 0, at 270 it's minus 1, at 360 it's 0. So these strategic points you need to know on the graph, and it's something else that we're going to look at further on, is what's called quadrants. Now from 0 to 90 degrees, if we draw a line down there, you'll be referring to this afterwards. This is what's called the first quadrant. So from 0 to 90 degrees, and this will make a bit more sense when we look at the diagram later on. So if you look at that, if we go on the curve here, the ratio, which is the y value, is actually positive. So we know that it's positive sign there. If we then look at the second quadrant, which goes from 90 degrees to 180 degrees, so this is called the second quadrant, we will see that it's also a positive ratio. Then the third quadrant goes from 180 degrees to 270 degrees. So that's your third quadrant here. And it's actually this time, you can see that the y value, or the ratio, is negative. So it's a negative value there. And looking at the fourth quadrant, I'll put it underneath here. So the fourth quadrant, which goes from 270 to 360 degrees, we've also got a negative value. Now we're going to look at all three graphs. This is sine that we've just looked at. We'll look at cosine, and we'll also look at the tan graph, tangent graph, and we'll look at each of the quadrants. So your first quadrant is 0 to 90, your second is 90 to 180, your third quadrant is 180 and 270, and the fourth quadrant is 270 to 360. So instead of drawing the graph out each time, we draw a quadrant system, and we can work out lots and lots of values of angles from that. And this is a precursor. We need all this work for the trigonometry, solving trigonometry equations later on. Moving on to the next graph then, we have the cosine. And the same sort of thing here. We have a maximum of 1. We have a minimum of -1, and that occurs at 180 degrees. And same again, it's cyclic, so it starts at 0, goes round to 360, and then it would continue on again, the curve at either side. So again, this has a period of 360 degrees, and we have a maximum of 1 and a minimum of -1. And also from there, if we put the quadrants in, because again we're going to be using these later on, if we put in the first quadrant, we can see that the ratio there, cos, is actually positive. If we look at the second quadrant, we see that we have a negative ratio. If we look at the third quadrant, we've also got another negative ratio, and then back to the fourth quadrant, you can see that we have got a positive ratio. And it's actually symmetrical about the vertical line here, which is x equals 180 degrees. And looking at the tan graph on your next page, you can see that we've actually got asymptotes at 90 degrees and 270 degrees, and that's where tan goes off to infinity. So if in your calculator, if you put tan of 90 degrees, you'll get a maths error coming up, and that's because the ratio is not actually defined there. The graph actually has a period of 180 degrees. It repeats itself after 180 degrees. And then if we look at each of the quadrants that we have, I'll make this is not an asymptote, it's just the quadrant here. So in the first quadrant, so from 0 to 90 degrees in the first quadrant, we get tan is positive. In the second quadrant, we get a negative ratio. In the third quadrant, we get a positive, and in the fourth one, we get a negative ratio. And you'll notice that there is no limit to the maximum and minimum value that tan can actually have. So if you put in tan of 100, inverse tan of 100 into your calculator, it will come back with an angle of some sort. Okay, now we're going to relate this to the quadrants now. So you need your three graphs in front of you, and what we're going to do is the trig ratio for any angle whatever. And this is what I was talking about in terms of the quadrant system. What we have is going in an anti-clockwise direction, we measure positive angles. So we go from 0 to 90, 180, 270, and then back to 360. Make that, see that a little bit better, like so. Okay, how does this help then? Well, looking at your graph, we can see that between 0 and 90 degrees, sine is positive, cos is positive, and tan is positive. So that's our y values that we're looking at, so they are all positive. So the A stands for all. Positive. If we then move on to our second quadrant, now again looking at your graph, you'll see from 90 degrees to 180 is your second quadrant. So sine was positive, cos was negative, and tan was negative. So that means that sine is the only one that is positive in this quadrant, the ratio. Then looking at the third quadrant, going from 180 or pi to 270, we can see it's only tan that was positive. So looking at your graph again, sine was negative, cos was negative, and tan was positive. And then from the fourth quadrant, going from 270 up to 360, we have sine was negative, cos was positive, and tan was negative. So we get a little mnemonic here, and that mnemonic is ASTC, and it stands for, you'll see at the bottom of this page, all Scottish teachers are clever. And the C only stands for clever. So if we look at the bottom of the page that you've got, you will see the mnemonic there. All is your first quadrant, so they're all positive. S for Scottish is your second quadrant, so it's only sine that's positive. Your third quadrant, tan is positive, and in your fourth quadrant, it's only cos that's positive. Now the reason that I've done this diagram is because it's for angles. Now this is really important. It's for positive angles. Now not ratios. We've got to get it clear between the ratio is the y value and the angle is the x value. So what we're looking at here is positive angles go in an anti-clockwise direction. So we go in that direction. So that's why I've numbered it 0, 90, 180, 270 and 360. We get exactly the same diagram, but for negative angles, and negative angles go in a clockwise direction. So going to the next again page, this is the diagram that we have again for the quadrant system. And what I'm emphasising here is we've got negative angles, and negative angles go in a clockwise direction. So for example, negative 60 degrees would look something like this. So it would look something 60 degrees going in that direction, so that would be negative 60 degrees. And that's all we're interested in our quadrant system. So if we have a negative angle, then can you notice we work from 0, then to minus 90, then to minus 180, and then to minus 270. What it's like is on the graph, it's going to the left-hand side of the origin, so we're having negative angles, and it will generate a ratio, it will generate a y value the same. So if we look again, we still have all the y values for sine, cos and tan are positive. Sine ratio, which is your y value, is positive. Tan is positive and cos is positive. And that's quite useful when we come on. We need this diagram to solve trig equations later on. And again, at the bottom of the page, just that little mnemonic to help you. I think what we can do with this one as well is to actually write on, that's going to be our first quadrant, second quadrant, third quadrant and fourth quadrant. And this is the diagram you'd be expected to draw when you're solving trig equations. So I've got the dog barking in the background and the cat's just come in to join me as well. Let me pause for a moment. So again, looking at the bottom of the page, you will find the little mnemonic again, and that's all Scottish teachers are clever. All positive, Scottish sine positive, teachers tan positive, and clever cos is positive. Right, moving on to the slide then. we want to do some examples of how we work out these angles using the quadrant system. So the diagram shows the position of OP, where theta is equal to 400 degrees, 700 degrees and minus 480 degrees. So on our first diagram, OP is just from the centre of the diagram, so we're looking for 400 degrees. So I have labelled my quadrant system, you can see starting at 0, 90, 180, 270, back to 360. It's going to go more than that because 400 obviously is more than 360, so I've taken it up to 450. So my diagram, hopefully you can see the angle that I'm looking for is about here. And that means I've started at 0, I've gone round, and I've gone to here. So that would actually be plus 400 degrees. So it's in the first quadrant. It's a positive angle, so we go in an anti-clockwise direction. So that would be O and P there. So that's the line OP. In part B, so that was part A. In part B, I've also made the x-axis very prominent because that's where we measure it from as well. Any acute angle, so that's relevant for the next part. Right, looking at 700 this time, our quadrant is a positive angle, so we go in the anti-clockwise direction. We start off at 0, we go round once to 360, and then we have to go round again to 720 because our angle is 700. So it's just a little bit before, and it's gone round a couple of times. So it looks something like this here. So we've started at 0, gone round to 360, and then round again to plus 720. And that would actually be the same as that angle there, which is minus 20 degrees. Sorry, that should be 700 degrees, not 720. So 700 degrees would go round one full turn and then round another to 700. And then that means that would be the same as the minus 20. Right, looking at the third angle, this time it's a negative angle, so that tells me the direction that I should go in is a clockwise direction. So the scale that I would use this time is going round 90, 180, 270 back to minus 360, and then I have to go round again because I want to go as far as 480. So minus 450 would be there, so we're looking to go round about at this point here. So it's going to look something like that. Now again, that's P there, I should have put that at that one as well, OP. So what we're looking at, we're starting at 0, but we're going in this direction, and we're going all the way around to there. So it lands in the third quadrant. So that's minus 480 degrees. And you can see there that it makes an angle of 60 degrees with the x-axis. And that's more important when we come later on. If we look at the first one, that also makes an angle of 40 degrees with the x-axis. So these are the quadrant system. I've not put first, second or third. I just want you to be able to draw this in terms of a positive and a negative angle on our quadrants. So what I would like you to do is, you can see at the bottom of the page, we're looking at exercise 8A, and I would like you to do question 1, the first column, and all of question 2. Notice that you have to work in radians as well, so do your quadrant systems the same. So if you pause the video, and then you can do some of the questions. It'll probably take you I would say a good 10 minutes, so pause that and then check your answers. Welcome back, and looking at the answers for these ones, if we look at A, it was minus 80, D was 165, and in the solution we've actually, if you can notice there, what we've done is we've got also the acute angle with this x-axis. It's quite useful to pop that in because we always measure it from this horizontal x-axis, whether it's on the left hand side or the right hand side here. And then you can see that here it's a negative angle, but the acute angle that it makes with this x-axis is 80 degrees. So moving a little bit further forward, for G, plus 280 goes into the fourth quadrant, and your acute angle is 80 degrees, and J minus 280 takes you a little bit past the 270, and you always remember you're always measuring it from this x-axis, so the acute angle that's associated with that is 80 degrees. Moving on to the next ones, question 1 part M. You can see here we've got in radians, it was a minus 5 pi by 3, so we go in that direction, so there's the other bit there, because it adds up to 2 pi altogether. And then question 2, all of them, leave them there, you can see, just making the line OP and then the acute angle with the x-axis. So looking at the first one we've got there, we had plus 400 degrees, so we start at 0, go all the way round, that's 360, and then another 40 onto that would give me 400, and so on. So check your answers for that, please. Pause if necessary, and then looking at the other ones, you can see there that we have got some radian measure starting, and then that's G and H for the next part. Okay, so that's the drawing the angles in the quadrant system, positive and negative angles. We're now going to look at the graph and how it relates to the 4 quadrants as well. So move on to the graphs of trig functions and how it relates to the 4 quadrants. Find 3 angles with the same trig ratios as sine 135 degrees. So on our graph we've got 135 degrees here, and if we take this up to the curve, then if we also take a horizontal line, we'll see that it actually crosses with some other angles as well. So if we draw that line in, that horizontal line, we're going to get another angle here, and we're going to get another angle here as well. Now, remembering we always measure it from the horizontal, so that there is the x horizontal line. And we can see that it's 45 degrees before the 180. So this one here is going to be 45 degrees, looking at the symmetry of it. And then looking at this one, that's 45. If we look at this one here, that's 45 degrees after 360. So that angle there is going to be 405 degrees. Now, if in your calculator you put inverse sine of 135 degrees, it should actually give you root 2 over 2, which is 1 over root 2, but your calculator's actually rationalised the denominator for you. So if we look at the value that we have on the y-axis, which is our ratio, that value there is root 2 over 2. So that means if in your calculator, if you put inverse sine of 45 degrees, we should get root 2 over 2. And if we also put in the inverse sine of 405 degrees, that should also give us root 2 over 2. Make sure you're working in degrees on your calculator, otherwise it'll come back with some strange answers. How does this relate to our quadrant system? And this is, you can use the graph, but the quadrant system will help you tremendously when we look at this. So what we wanted was an angle of 135 degrees. So if I draw in 135 degrees, looks something like that. That's 135 degrees. Now we're interested in the acute angles, so the ones that are associated from our graph as well. So we've got 45 degrees in here, and that gives us an acute angle, which is also called the principal value. So this 45 degrees is the acute angle that's associated with 135 degrees and is known as the principal value. So PV, principal value. If we look at on our graph as well, we had 405 degrees. So 405 degrees would be this angle here, and that's going all the way around to there, which is 405 degrees. And the acute angle that's associated with that as well, surprise, surprise, is 45 degrees. Now to work out the acute angle for each one, what we do in the first quadrant, it's just theta itself. Okay, so theta is the acute angle. So we'll call that theta in there. Or we subtract, if it's a big angle, you subtract 360 from it. If we look at the second quadrant, the acute angle, or the principal value, is equal to 180 degrees, take away theta. So the angle that we have at this point was 135. So that would be 180 minus 135 would give us 45 degrees. So that's our principal value, or our acute angle. In the fourth quadrant, the acute angle, or the principal value, is equal to theta minus 180 degrees. So that's everything past the 180. And in the fourth quadrant, the principal value is equal to 360 minus whatever your angle is. Okay? Right, same idea with the next example. Find three angles with the same trig ratio as 118 degrees. So if we locate 118 on our graph, I'm then going to take a horizontal line across, and that will allow me to get quite a bit more than three angles, but let's just see what they are. So the angles that we have there is going to be this one, and we've got another one here, another angle here, and another angle here. And you can see we've got a bit of symmetry going on before and after 180 degrees. Now on your calculator you can see here that we can get a ratio. So if you do the cos of 118 degrees on your calculator, you should find that it's minus 0.47. So on our graph we can put minus 0.47. So it's a negative ratio. So that there is a negative ratio. So how far is 118 from 180? So that's the angle that we're interested in terms of our quadrant system. So we can see there that that's actually going to be 62 degrees. So that part there is 62 degrees away from 180. Now how does that help us? Let's look at the quadrant system that we've got. So there's 118. So if we to work out a principal value, as we said before, so a principal value is going to be equal to 180 take away 118, which gives us 62 degrees. So this angle here is 62 degrees. Now, because the ratio is negative, cos is negative in the second and the third quadrant, and we can see that from our graph. So we've got cos is positive here in the first quadrant, cos is negative in the second quadrant, cos is negative in the fourth quadrant, and cos is positive. Cos is negative in the third quadrant, and cos is positive in the fourth quadrant. So that means, looking back at what we've got here, you can see that that's the first quadrant, that's the second, that's the third, and that's the fourth. So what we're interested in is we've got an angle there in the second and the third quadrant, and then we go round again, so that goes back into the second quadrant again. So the cycle keeps on going. So we can work these out in our quadrant system. So if cos is negative in the second and third quadrants, that's because all Scottish teachers are clever, remember, we can see from here that because it's a negative ratio, I can also draw in another angle here, and that's 62 degrees in there. So the other angle that I can get is 180 plus 62 degrees. So that's equal to 242 degrees. So if we look back at our graph, that angle in there is 242 degrees. And we can work out exactly the same way the other ones that we've got. So we're going to have minus angles in here at the left hand side. So we can work out that is 62 degrees after minus 180 degrees, and that's 62 degrees just before it, so we can get those values. So looking at the quadrant system again, what have we done? We've located 118 degrees, which is in the second quadrant. From a calculator we found out that it was a negative ratio, which is what we expect because cos ratio is minus in the second quadrant. We can find out this principal value, which allows us to go into the third quadrant and find out the other angle, which is that one all the way around there, which is 180 plus the 62, and so on. So how would we work out the angles from the graph? Well, we've got theta is our original one, which is 118 degrees. Then the next one we can work out as 180 plus the 62 degrees. Then the next one would be 540 minus the 62 degrees. So the three that we could get was 180 degrees, 242 degrees and 478 degrees. If you do the cos of 118 degrees, it's going to be the same as the cos of 242 degrees, which is also the same ratio as 478 degrees. And it should all work out as 0.47. You give that a go on your calculator and see how it works. Right, let's do some examples on this. Example 6. Express in terms of trig ratios of acute angles. So when it says acute, we're looking for principal values. What would actually be the same as minus 100 degrees and so on. So I've done a few diagrams here, and what I'd like you to do, the first one is a negative angle. So remembering for negative angles we go in this direction. We go in a clockwise direction. So I'm going to draw in our minus 100 degrees. So it's going to be roughly from there to there. That's minus 100 degrees. Now, because it's in the third quadrant, it's only tan that's positive in there. So the ratio for the sine of minus 180 is going to be minus overall. Now, how do we find the acute angle? Well, the acute angle is in here. And you can see from the diagram, it's 80 degrees before. So what we've got there, our acute angle or our principal value is 80 degrees. So we'll pop that in, that's 80 degrees in there. So if we wanted to work that out, the sine of minus 100 degrees is going to be exactly the same as minus the sine of 80 degrees. That's our principal value that we've just found. Now you can check that using your calculator just to make sure. So that's A. Part B, we're looking at the cos. Now the cos of 330. 330 is just before 360, so it's about there. So we've gone in the positive direction round, and that's 330 degrees. Now to get our principal value, so our principal value is this one here, it's actually 30 degrees. Now we're in the fourth quadrant. The cos ratios in the fourth quadrant are all positive. So that means that the cos of 330 degrees is exactly the same as the cos of 30 degrees. Again, if you pop that in your calculator, then you can see that they're the same ratio. So we're looking for a positive angle, so the positive angle went in that direction. Right, third one then. C, tan of 500 degrees. So we've got to locate it. Where is it in the quadrant system? So I've gone from 0, 90 and round to 360, 450 and then back to 540. So 500 degrees we've got to be able to draw on here. And 500 degrees is going to look like so. Now we've started here and we've gone round, and that's 500 degrees, which means that we want 540, so 40 degrees is going to be our principal value. It's the tan of the angle, so it's tan of 500 degrees, and that's actually in the second quadrant. Tan in the second quadrant is only sine that's positive, so the ratio is actually going to be negative. So it's going to be exactly the same as the minus tan of the principal value, which is 40 degrees. Again, try that out on your calculator, make sure that works. What I'd like you to do to practice this is exercise 8C. And if we look at the very first one, we want to express in terms of a trig ratio of acute angles. So we've got 240 degrees, that's the very first one, 240. So 240 is roughly about there. So we've gone from there to there, which is 240 degrees. Now that means that our principal value is this one here. Now all are positive, sine are positive, tan is positive, and cos is positive. And we're looking for the sine of 240 degrees. So that's going to be in the third quadrant, so it's only tan that's positive. So it's going to have a negative sine ratio, so it's the same as the minus sine of the principal value. And to get the acute or the principal value, it's 240 minus 180. So that angle in there is 60 degrees. So it's going to be sine of 60 degrees. So what I'd like you to do is draw a diagram for each of these. And this is really, really important for when we go on to a later chapter when we solve trig equations. So if you do B and the other ones that I've circled here, I'll stop the video, take about 10 minutes or so. Sketch them as neatly as possible, please, using a ruler and pencil. And that should help you with your calculations. Welcome back, and the solutions to these ones I will just scroll through for you. You can see here the diagrams that I've drawn. Take a moment to have a look. You may want to pause the video. I'm just going to scroll through them now. So B and E, F, H and J, then K, M and O, and then we're working in radians now, going from P onwards. So set up your quadrant system, going to R, and then the last three on the next page, working in radians, look like that. So you must be able to work in degrees as well as radians, and it's fraction work. You do have your calculator to help you out. The last part that we're going to do in this chapter is related to C1 when we do transformations. And what I'd like you to do is take a few minutes to have a think about what these transformations are. We've got 7 of them altogether. And what you need to be able to do is take any of the trig graphs. I've used sine here. So we always think of y equals sine x and then what's happening to it. So if you can remember, I'd like you to take a few minutes and pop in what each of these transformations are. So remembering this one, stretch parallel to the y-axis scale factor a. So in this case here, we're multiplying the y-coordinate by 2. So we're going to get a maximum minimum of 2. F and the a is inside the bracket. It's a stretch scale factor 1 over a, or divide by a, parallel to the x-axis. And that means this one here, instead of sine x, we've got sine 3x, so we'll have 3 times as many within the x-axis. So the period, as we saw before, was 360. This one will have 360 divided by 3, so it repeats itself after every 120 degrees. Transformation, and you know that should be a transformation, or a translation rather, of minus A0. This one is a translation of 0A. This is a reflection in the which axis? I change the sign of Y, so it must be in the x-axis. This is a reflection in the y-axis, and this is a translation. It's a bit like complete the square. We will have AB, so we move it A units to the right in this case here, and B units up. So looking at the graph that we have here, we always compare it to our original y equals sine x. So it's very important for you to know all the strategic points on the graph in degrees as well as in radians. So maximum of 1, minimum of minus 1, repeats itself after 360 degrees, etc. So this is what we're going to do to do some transformations on these graphs. Right, what you can do is look at the next page, and what we have here is, can you tell me what the equation would be of the blue curve that is here? So this is the original, the red one is y equals sine x. What has happened to that? If you look here, it's got a maximum of 2, a minimum of minus 2, so the blue one must have an equation of y equals 2 sine x. It's been stretched parallel to the y-axis scale factor 2. None of the x-coordinates have changed at all. So you can see there that this one is 180 degrees, that's 90 degrees there. Forget these in terms of pi, and that's 360, etc. and so on. Looking at the next curve, what is the equation of the purple curve? Again, this is our original sine curve, and what's happened is it's been moved up, so it's gone from 0 up to 5. So we have a translation of 0, 5, or the purple one has now become y equals sine x plus 5. So it's a translation of 0, 5. Nothing else has changed about it at all. It's not moved in any direction. So what I'd like you to do is have a go at sketching the graph of three sine 4x. What's its period? What's the maximum? What's the minimum values of this curve? And you can see below, I've put it there, you're going to have 4 times as many. This is a stretch scale factor 3 in the y direction. So I'd like you to put all this information, period, maximum, minimum values, on the axis, etc. I've done it in degrees because that's how Desmos draws it, but you can put these into the intersections, knowing that from 2 pi, which is 360, we've actually got 1, 2, 3, 4 sine curves, because it's 4 times as many. So I would like you to give a go of sketching that or on your diagram. I don't think you've got that in your booklet, This is the actual answer to it. So what I'd like you to do is give it a go of sketching, but put all the points on here and all these strategic points as well. That's this unit finished. I expect this to be finished today on Tuesday the 14th of March, ready to start on Friday the next chapter, and the booklets are in the bookcase at the left hand side of the door in the classroom. Any questions, just email me or on Canvas, that's absolutely fine. But you need to know this is the precursor for what we're going to do on the trig.